Hello all. Today we are going to see about a different name called roaming RAG. RAG means you would have been known Retrieval-Augmented Generation. What is the roaming word? Why it is coming here? It's a it's not a different dimensional concept. It's a pretty easily quickly pickable concept, but it's nice to learn. It's a different methodology if you have a good structured document, I feel. Basically, it also does the same. The outcome is same like a RAG. If you have a text document, then it will provide you the, if you ask a question, it will answer you. That is the overall concept. But how it finds the answer is the core difference part here, I feel. You can understand, right? So let's see what is roaming RAG, what is the concept behind it. Then let's continue speaking what is the advantage and disadvantage. We will see at the last. Okay. So today, if we see here, right, roaming RAG, a RAG without a vector database. Basically, it tries to eliminate the vector database as a component. If you see, it is written by Arcturus Labs on November 21st, 2024. It's been already 7 months. Let's see and let's deep dive into the concept, how it works, everything. I think their blog is well written. It's so nice. I will attach the link in the description also so that you could also see it. So if you see here, right, roaming RAG, let's face it, RAG can be a big pain to set up or even more of pain to get it right. I don't think it's pain to set up, but it's slightly pain to get the right answer. That's what they are coming to say here. There are a lot of moving parts. First off, you have to set up retrieval's infrastructure. That is true. Basically, they are saying we need to set up the RAG data, I mean vector database. Then you need to hit the query. It should be converted into embedding. That should be given back with similar chunks. That is a retrieval infrastructure, I feel. This typically means setting up a vector database and building a pipeline and ingest the document, chunks, then chunk them, then convert into vectors and index them. What I typically said, like we have a document, text document, we need to chunk it, we need to convert into embeddings, we need to ingest it, we need to take the user query, embed it, query the vector database, retrieve the chunks, then pass it to LLM. So in the LLM application, you have to pull in the appropriate snippets from the document and present it to the prompt so that it can make sense to the model. This is what the RAG is. And the things can go wrong if the assistant isn't providing the sensible answer. You have got to figure out if the fault of a prompt, chunking, and embedding. Yeah, that is true. If a RAG is not giving a good right answer, right, then where the faults happen? Is it in the prompt side or in the chunking side or the embedding model or the retrieval side? There are so many moving parts is what I personally feel, and that's what the author is also coming to say here. If your RAG application is serving documentation, then there might be an easy alternative. Rather than setting up a traditional RAG pipeline, put the LLM assistant to work. Let it navigate through the documentation and find the answer. I call this roaming RAG, and in this post I will show you how it is done. So basically, I think this is not that much important. So basically, what the author is trying to say is the LLM should be also finding the document or the relevant chunks from the documentation. That's what he's coming to say. And let's see how he calls it as roaming RAG, and let's see how it is done. Okay. So if we see the big idea, actually, this is an old traditional model. How it is done, they have mentioned over here. However, you are looking to answer, this is a small RAG thing explained over here. So the important point is reference book. How do you find information you need in a reference book? How do you find information you need? Probably you will open up the table of contents, then review the chapter and section that might be useful, and then find the content you are looking for. This is what we are trying to make the LLM to do this process when you have a very big document. Okay, simple as that. So what they are coming to say here is, if you're looking for an answer in a relative small set of well-organized documents, then hierarchical directory might be a pretty good approach. So if you have a small set of well organized documents, this is also a very important point to be considered when you are having a document or a confusion. Should I choose roaming rag or should I choose traditional rag? Where can roaming rag come into the picture? They have given some examples. Legacy code, which organizes the laws into a hierarchical of title, chapter, section, and legal code and paragraph. Technical books organized into parts, chapters, sections, subsections, and paragraph. So all these example are coming to say that these are all well structured documents. You can understand, right? Which has parts, which are chapters, which has sections, which has subsections, which will have a paragraph. You can understand, right? The document which the roaming rag can understand will be a well structured document. A product owner's manual, curriculum or syllabus, corporate policy manuals. So these all will be a well structured one. The big idea of roaming rag is a craft of simple LLM application so that the LLM assistant is able to read hierarchical outline of the document and then rummage through the document by opening sections until it find and answer the question that at hand. Since roaming rag directly navigates the text of the document, there is no need to set up retrieval infrastructure, and fewer moving paths means less things you can screw up. This is what author is coming to say. So from this point itself, I think you would have now started sensing what is happening in this roaming rag. In this roaming rag, you will have a well structured documents as a markdown, then that will be passed to an LLM, then it will figure out what content should it pick up for answering the user question. Now you will have your question in the mind that if I have a, a 10,000 token a million token length of book, I mean size of book, how will I pass it to LLM? Now Gemini can handle a million tokens, but let's keep that. If you see, it's not a scalable solution, right? It will be constrained to the context window of the LLM. So it is not like that. So what they are saying is the LLM assistant will be able to read the hierarchical outline of the document. So it is not going to read the whole document. It is going to read the hierarchical outline of the document, which means it will start reading the chapters, then it will pick which chapters to go into to answer the question, then it will see all the sections inside the chapter, then it will try to answer what is the section needed to answer this user question, then it may go to subsection, and then it will go inside the paragraph. Once it reaches the paragraph level, for sure it is none other than a chunk which we retrieve from a vector database. So it takes up the paragraph and tries to answer the user question. How it is going to reach the paragraph is known as roaming rag. So it initially starts with the chapter, looking at the chapter level, then the section level, then the subsection level, then only it reaches the paragraph level. This is how it navigates to the end paragraph. That is called roaming rag. By opening the sections, by opening each and every paragraph, section, subsection. So that's what they are mentioning here until it finds the answer to the question at hand. Since roaming rag directly navigates to the text document, there is no need for retrieval infrastructure. So because we are giving a document, right, as a big text file, right, as a markdown, so we don't need to set up any infrastructure in the sense we don't need any vector database or any other things. So there will be less moving parts. Because there is less moving parts, we don't to want to worry about the, I mean, not to worry about, we have less complexity. So because of less complexity, there will be less chances of getting screwed up. That's what the author is also coming to mention here. Then let's see a demo here. Can we come to the demo at last? Okay. Basically, I'll try to explain how it works. Then I will move on to the demo part. So when it comes to how it works, right? The idea is pretty simple. It is just the model with the abridged version of the document. So we need to now understand what is the abridged version of a document. It's like a well structured document which has a navigation ID with it, so that a model can easily pick up that ID to expand or to go deep inside it. Everything can be done over here. So let's come to the average document below. If we see what is the prerequisite is none other than a well structured document. That's very important. Then the whole premise of this approach is the assistant looking the outline of the document and navigating it. So once the document, a well structured document is there, then it's none other than the LLM will be looking into the document and going deep into each and every section until it reaches a paragraph which it thinks as an answer for the user query. Then the LLM will start responding the answer. So in the document, titles and heading should be clear and self-explanatory. Each section has an opening text that further clarifies the contents of the section. Each section of the document should only contain subsection that logically fits within the topic of the section. There should be a ton of top level sections. So these are all the things which we need to take care while we have a well structured document for this roaming grab. So can we see how the well structured document will look like, how it is prepared? So Jeremy Howard proposed LLMs.txt, which is here. If you see here, right, the /LLM.txt file, basically it is a well structured document of your HTML page representing it. It should be like a sitemap.xml file, which is for a project. I mean, which is for a whole website. This should be like this llms.txt should be like a whole understanding of your website for an LLM. That is for a crawlbot. This is for an LLM. That's the difference. So if you see, everything should have a primary title and the optional description goes here. Then optional detail goes here of the title. Then the section names should come here. After that, if a section has a link to it, right, as each and every website will have link so that it will reach the page, like contact page, blog page, document page kind of thing. Then we will have a optional links also. So if you want to see an example here, this is fast HTML's version. So they have given a description of fast HTML over here, important notes over here. Then they mention a subheading of docs. Then the docs have the URL defined over here. Then the example also has the URL over here. The optional part has also optional is a subheading over here. So that also has the links to it. This is what he proposed. So every website should have a llm.txt file. He proposed in September 3, November 20, 2024, September 3, 2024. So this is what every website should have, so that it's easy for the LLMs to crawl the website, is what he thinks. So if we see here, right, there is a cursor website have really did it, and llms.txt is added over here. If you see here, right, this is a cursor websites docs.cursor.com/llm/full .txt. So they have cursor.llms.txt and also full llm full.txt. LLMs.txt will have all the links to the website which are all important. LLMs full will have all the document needed, all the information needed, all the links needed for the LLM to answer. That's what they have given here. We'll see the demo later point. Yeah, let's then what is a bridge document? A bridge document is something like, as soon as the roaming RAG application loads the document, it parses the text into sections and the subsections and produce an abridged version of the text like this one taken from cursor llms.txt. So what is an abridged document from the real document? If you see here, right, AI review beta, then here's a section collapsed expand with the section ID 07F3277D. There is a ASCII value added here, I think so. I'm not sure with the name of the value here, but a unique identifier is added here so that if a AI review, I mean, what to say, and it also given a 100 characters of description. This is a subheading over here. That subheading also have a section collapsed to expand it with a section. They would have added a unique identifier over here. Like that, each and every subsection is added. Each and every heading will have it. So once the model comes here, if you ask a question in Google API keys, then it directly comes into custom API keys section over here. Then it expands, then it will see the Google API key, then it will expand the Google API key with this unique identifier. Inside that, it will have the paragraph content. Once with that content, it uses the user query and try to answer with the Google API key. I mean, Google API key paragraph thing. If you see here, right, we keep a top level heading. We preserve the first 100 characters of opening text from each section. We preserve the second level heading but without any subsidiary content. Each section is provided with a unique digit hexa identifier. It's not a ASCII value, sorry. It's a hexa identifier. Each section heading is followed by a guided comment for the model. Section collapsed. Expand with the section, expand the section, then the identifier should be given. So the model wants to expand a section, right? Then it will come up with the tool calling expand section. Then the hexad identifier will be given as an input. So it expands and give back to the LLM as a response. Splitting up the document like this is not terribly difficult. In these 300 lines or so lines of code, there is a repository link to it. Let's go into that after going through this. I'm using markdown it to split the document into sections, give them a unique identifier, then make it possible to easily access and expand subsections using their identifier. So markdown underscore it is what he's using to expand the section. What is inside the expand section? Expand section is like a tool which exactly expands the unique I mean hexa identifier given as an input. So this is also will be like a structured output, because you say what is the type, what is the description, what is the pattern, and what is the overall description it should generate. This is the schema basically. So required is the section ID over here. You can understand, right? So I was planning to make a video on structured output also. Give me some time, I will do that too. So the final touch is to create a system message to explain that the assistant task is to help the answer question from the associated llms.text. I explained the idea of llms.text and the manner in which the assistant is to navigate the document and answer. This is a system prompt included over here. We will go inside the system prompt and also see how it works. Let me quickly complete this video and try to make a separate video for here how the system prompt has been included and what is the 300 lines of code. Let me put as a technical part of the same page because the video will be so long else. In action, the assistant might open several sections at the same level so it looks the content that satisfies the user request. So you understand, self-explanatory. The assistant can dig deeper into the text by opening the section and then read the new content within the section and choose to open deeper subsection also. So both the point, what are they saying is it is assistant, the LLM's decision to open a section or a subsection or dig deeper. If it didn't get the relevant answer for the user query, it will still dig deeper. Okay. Because the abridged document shows two level of unopened sections, the assistant can optionally skip a level of detail and dive two sections deep also. So here they have mentioned, right, we present the second level heading without any subsidiary content. So the secondary level also shown here, so it can easily directly go inside the subsection level also. So this is a very important point. There are actually a couple of tricks that left out. For some reason, I didn't design the expand section tool to take a list of IDs. This would have allowed the assistant to open multiple sections in parallel, thus that it would save a bit of time. So it is now opening the sections sequentially, not parallelly. So that would save a lot of time is what he mentioned. This is one point. Then I would also did some experimentation with a collapse section command that allowed the assistant clean up open sections that were no longer relevant to the conversation. This is other part. He was trying to make a collapse section. Now we have a tool called expand section. Like that, he was trying to make a collapse section so that the assistant will close the section after reading it if it doesn't require it. Unfortunately, the assistant would either never use the tool, or if instead that is the tool is being used, then the agent would be in discriminate discriminately on at the wrong time. So at the end of the day, the author is coming to say that assistant is not using the tool, or if it use also, it is not going in a correct path. Instead, I opted to close all open sections at the beginning of the question itself. This is what happening currently. So all sections will be closed at the beginning itself. This is shame because this is very very important line. This is shame because if the user has a follow-up question about the topic, it would be better to keep the section open. Oh well, next time. So it is not happened currently. So but he will try to make it as the next time. So if we have the user have a what to say, user have a follow-up question. Now again, it should come through all the section by section, chapter by chapter, and go deep, dig deep inside and try to answer the query. There are times when roaming rag is unable to find the information it needs. Okay, so likely this is because the document isn't well structured. First point. Okay, or perhaps the heading aren't descriptive enough for the model to make sense of them. This is the second point. But sometimes the model could also just overlook the right section. That means it will skip the right section and move to the next sections. So that is the third point. When this happens, I have prompted the model to apologize the user and recommend other ideas for tracking down the answer. This is what he have done if the roaming rag doesn't answer properly. Okay, let's come to the conclusion. Once the thing, the underscore is the roaming rag isn't okay. One thing to underscore is roaming rag isn't drop-in replacement for traditional rag. Understand this. This is a very, very, very important line. Okay, it's not a drop-in replacement for traditional rag application. Roaming rag only works when the document and questions are well organized, as described above. There is also a cost to consider. Roaming rag might take several lookups before it finds the information it needs, and the prompt can be also long. So prompt caching is advised. So the cost part will be so costly to answer this for each question. So both we need to have a very structured document, and the cost will also be increased. This can be used at a documentation of a website so that it should be always precise, right? So we can use it over there. That is a good use case. With roaming rag, the information retrieved is always presented within the context surrounding with the documents. So this is the benefits of the roaming rag. And there is that means they are saying it only grounds to the document which we have provided. There is a very, very, very less chance for hallucinating. The other main benefit is that there is no infrastructure setup for roaming rag is required. So only all 300 lines of code will take care of this. No vector database setup, no chunking, no retrieving mechanism. Nothing is required on that side. So only we need, only we need is a well structured document for the LLM to answer, and this 300 lines of code is all required. So this is what roaming rag. So let's see the demo and complete this video. Next video will go deep dive into the code section. Okay. So now the cursor LLM full, here we have shown the full LLM's full .txt of the cursor. So it has a very long text. Basically, I hope so. This would have been at least a 50,000 tokens minimum to 1 lakh tokens. So what the user is asking, how does cursor's tab auto completion feature differ from Copilot? This is what the user question. So let me check the relevant section about the cursor tab feature and the Copilot migration to answer the question. First, it calls the expand tool section, and the section ID is how it finds the section ID. So this is the abridged LLM.txt file. This will be as soon as you pass the large txt file, automatically it converts into abridge.llm.txt file. This is how it looks like. So custom API, it would have the subheadings, models, it would have the 100 characters, then the subheadings. So like that, it will have all the headings, subheadings, and 100 characters of the heading. So what section it have taken? 1951E. Okay, I don't want to read it, right? Yeah. Where is this? Oh, okay. Here it is not showing abridged document. This is not a fully abridged document because user doesn't need the section ID and all over here, right? So the output will be overview. So we need to search for overview. So this is one overview. This is the two. How many overviews we have? We have overview. This is one overview. 2, 3. Okay, I think yeah. The cursor tab. This also speaks about cursor tab. The question is also cursor tab. So it has picked this overview. Cursor tab is our native autocomplete feature. It is a powerful copilot. It starts from here. It goes inside. So second, it goes to another section. Migrate from GitHub Copilot. This is also another section for the second part of the code. So, okay, let's see what is there in the overview. This overview is full text here. The UI part is here. Then the toggling also here. Everything is passed and migrate from GitHub Copilot. If you see migrate from GitHub Copilot, this is the subsection what it requires. The content will be like this. So based on this both overview and GitHub Copilot, it starts answering based on the information from the overview and migrate from GitHub Copilot section. Here's what I find: edit capabilities, multi-line changes, contact awareness, and the usage. Everything is over here. This is what you understand, right? This is what roaming rag is. I can't ask a new question over here. It asks me to sign up, but I'll try to set up in the whole repository itself in the next video. But this is what a roaming rag is. If you have a well-structured document and a small level document, then roaming rag will be useful for you without setting up any of the vector database or any of the infra side. So this will be great, right? Uh, Let me know if you need the technical part of the creating the repository, replicating repository, and trying to do it for our own documents. Let me know that. That's it for today's video. Let me see you all in another video, maybe with the technical documentation or any other new video. There is another video. Qwen 3 new model is also released. I didn't make a video on it. I will try to make a video on it also. I think I have made so many commitment in a single video or last two videos. I will try to make it up. Yeah. Thank you so much. See you all in another video. Bye.